Hey everyone, it's Mr. Canfield. Today we're looking at chapter 39, Slope Fields. Slope fields are awesome because they have part of my last name in them. No, slope fields are awesome because they're easy. Basically slope fields are kind of like if you were to look at a weather map and it showed you like possible wind paths, and it's like right here. You can just kind of imagine like, oh, this is kind of like if I drop an object in the wind, where's the wind going to take it? So if we were to drop a dot here and follow the slope field from there, you'll see these little dashes are all slopes. So doing them is easier than understanding them. So we're going to do one first, and then we'll talk about what the heck it means. So I'm going to drop down here to number 1, and I'm just going to do this in the book because the table's great. So it says dy dx is equal to y. This is another way of saying slope is equal to y, right? Dy dx means slope. So what's the y value of this point? 1, right? So at 1, 1, the slope is 1. That's all we're saying. So like what we can do is we can use a table, and I do my tables a little bit differently. This is a little bit better than the way that I do them though. So like these are our x's, I'm assuming, these are x's. So I guess these are probably our x's. I'll say that these are my x's going this way and these are my y's going this way. So at the x value -2 and the y value 2, what's our slope? Well, our slope is equal to y in this case, so my slope is 2. At the x value -2 at the y value 1, my slope is 1. At the x value -2 at the y value 0. Do you see what's going on here? It's just whatever our y value is that winds up being the slope. And so since these are my y values for this one, I don't know if I like this way. I might want to do it the other way in the future. So I'm new to these tables. I don't do the tables this way. I can show you how I do the tables. Mine is a lot more writing, in all honesty, but sometimes more writing is better. Okay, so anyway, all I got to do, so at the point -2, -2, 2, I have a slope of 2, which I just got to go here and I rise 2, run 1. Now I don't really have enough room to like figure that out. I'll go backwards. So I got a slope of about that. And the best I can do is an estimation, but I draw a little slope there. And I just keep on going. So like at -1, 2, I have the same slope of 2. So I'm gonna do my best to make it look parallel to that one. And so for all these ones where the y value was 2, I can make a slope of about 2. You're not gonna get this perfect. So we just keep on going. So then I go to my next one, which says, well, these are all like -2, 1. All my y values here are 1s. That means all my slopes are 1s. And remember, a slope of 1 is up 1 over 1. So I just try to imaginarily connect this to like the next corner when I'm drawing my 1s. The key thing is that you can tell it's a different slope than the one up there. 0 is a nice easy slope to draw. Then -1. And so all you're doing is you're marking these slopes. I said it was easy. I didn't say it was fast. It's tedious. So now we're going to show an attempt at what we call a solution curve going through the point 1, 1. So what I'm going to do is I'm going to go to 1, 1, bop, drop a point. And so the thing is, the slopes that I drew, there are an infinite number of slopes not shown. And you can kind of imagine those slopes slowly changing steepness. So what I'm going to have to do is, yeah, I start out at about this slope, but by the time I get up here, I'm even steeper. And then, oh, over here, look, by the time I get down here, it gets flat. And what's it gonna do after that? Or is it just gonna do that? Yeah, it's gonna be like, nah. And I can tell you from experience that this turns into like ln or something like that if we solve this differential equation. Did we solve differential equations in your class last year? Probably not. That's probably next, isn't it? Yeah, differential equations is next. So we're gonna learn how to solve this and actually get a function, and this one turns out to be, or no, this one turns out to be like e to the x. That's what it is, right? Because we get ln y. But it's this weird, like, if I had started somewhere else, I'd get some other kind of tracing back function. And it's going to look different. And if you remember, okay, so I got to talk about what a solution curve is. If you remember that antiderivatives, there's an infinite number of antiderivatives. And so slope fields help us look at that infinite group of antiderivatives and figure out, okay, depending on where we start, we get a different result. So let's look at our next one. I'll show you the table that I use, or you can use Stu's table. They're both fine. So the table that I like to use is, I'll say x, y, like this, and then I'll say dy dx. So I'll do like -2, let's see, how many times does -2 as an x show up on? 5 times. And then I'll show -1, -1, -1, -1, -1, and then 0, 0, 0, 0, 0, 1, 1, 1, 1, 1, 2, 2, 2, 2, 2. And then I'll do -2, -1, 0, 1, 2. -2, -1, 0, 1, 2. So as you can see, mine is a lot more writing, but it can lead to, for some people, it's an easier way to organize this. So dy dx, what is dy dx equal to? X plus y. Oh, super easy. -2 plus 2 is -4, -3, -2, -1, 0. I just add, right? Our next one was what? -3, -2, -1, 0, 1. Interesting. So I definitely think Stu's method is better for this. But again, mine could be, you might find mine helpful. So interesting. So now all I gotta do is go to each of these points.
Good job. Oh, are you all done?
So like -2, -2 is -4. Ooh, -4. That's like just, you're not gonna be able to draw that very easily.
What can I give you?
So we're just going in and we're doing our best with this. So -1, -2 was at -3. So basically, I'm going to try to do my best with those. The thing that's, the zeros should be obvious, right? As we go in, so like 1, -1 was 0. Like I went in and all the places where I had a 0 slope, I draw a 0 slope. Then it looks like all the ones right above 0 get a 1 slope. Oops, that should be a 2 slope. Then a 2 slope. For some people, these are really, really obnoxious because, oh man, I am botching this. Like, whoa. This is probably the worst I've ever done on a slope field in my life, and I'm not kidding. In my whole life, this is the worst slope field I've ever done.
Maybe shrimp.
Maybe it's shrimp? That's awesome. That's not surprising, the roseate shrimp. Let's see, so at 1, 1. So this one looks like this way it gets steeper and steeper. This way, it's gonna flatten out. Oh, and then like go back. No, I gotta be wrong here. Flattens out. Is it like that? All right, since my slope field's so bad, it's a little bit tricky to figure it out. Why did he start with 2 of the worst ones? So I'll go back to using his table for this last one here. Okay, so for our last one, this one will actually work out nicer. So let's see, we're doing x divided by y, right? With a negative. So I take x divided by y, I take the opposite of it. I'll stick with x as being here and y as being here. So negative 2 comma 2, we get negative 1 and then a negative, so a positive 1. Oh, so anytime they're opposites, we're gonna get a slope of 1. With 0 over 0, we're gonna get does not exist, we're gonna get an undefined. Wait, that's anytime our y value is 0, right? So let's see, then these are, so I got another 1, got another 1. So then I'll stick with x values of negative 2 first. So that's 1. Then that's going to be what? Negative 2, positive 2. Then negative 2, then negative 1. Then if I stick with an x value of negative 1, so that's going to make all my tops positive 1. So that's 1/2. Then negative 1, then negative 1/2. Right, let me make sure. I don't want to rush. X is positive 1 because of the negative over negative. Yeah, okay. Good, 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 good. Oh, x is 0. 0, 0, 0, 0.
You're all done?
And then 1, so all my tops are negative 1 now. And my bottom is 2, so negative 1/2. So this one's kind of trippy looking, but then I am expecting the actual slope field to be super awesome. So let's see, negative 1, and then I'm assuming 1/2? Yeah, positive 1/2. And then so all my tops are negative 2, so then negative 1,
You all done?
negative 2, and then
Yuck.
2. Okay. So a slope of DNE does not necessarily mean vertical, so we actually leave it out. I like to put vertical ones in there. That's all my y values are 0. So I like to put vertical ones in there. A lot of times you'll see they leave it out. Let's see. Then when my x value is 0, except for there, we have a slope of 0. So slope of 0, slope of 0, slope of 0, slope of 0. What is this?
Can't drink it. I need creamer.
My wife just put a cup of coffee next to me that I did not ask for, and I was like, what is, it smells really good. She used her Nespresso. I just use drip coffee because I drink too much coffee. So at negative 2, 2, it's 1.
All done?
At negative 2, 1, it's 2. Undefined. Negative 2. Negative 1. All right, at first this might not seem good. Trust me, it gets good. So at negative 1, 0 we're DNE, but then negative 1, 1 we're 1. And then we're 1/2, right? Then negative 1 and negative 1/2. And zeros. Then at 1, 0 we're DNE, but then we're negative 1, negative 1/2. Then down here we're positive 1, positive 1/2. Are you noticing the shape? Then we're negative 2, negative 1, negative 2, negative 1. We go up to 0, 2. If I go this way, see how it's curving down this way? So that means, okay. So make it steeper and steeper and steeper. Oh, hit that. Straight up and down. Oh, keep going, right? Kind of following these curves. See how I'm following like the general trend of things? Turns out this is the slope of a circle at any given point. Looks like a circle, one type of circle. At this point, I continued filming even though I was done. So feel free to stick around for some embarrassing moments or stop the video here. Well, here, let me check out, see what you did. Don't feel bad about it. All right, let's see. Oh. Okay. Well, so like one of the ones you got wrong, like you got 3/4 of it right. You dropped a negative, that's all. No, you basically got it right. The only thing you messed up was a negative. No. You're not stupid. This is exactly what, like, that's the stinky part about multiple choice questions.
On Rosie's nose.
Oh, Rosie.
Look at call Rosie.
Rosie, what are you doing?
Is it still on there or did you get it off?
She finally got it. I did see it though. Teacher Rosie, they need you. Let me try again. I don't want to hurt you. Okay.
Hey, you're doing a great job, okay? You should believe in yourself. Sometimes we get bad scores on multiple choice. It doesn't mean we're stupid.
She was nice for once. I don't know what happened. I was filming this whole time.